Well, once again, thank you very much. I'm very pleased to be able to talk about that today. So here I will present one of our solutions, which is the Mixolab, the instrument that you can see here on the screen. And I will try and present some applications that we have developed over the years, and that might give you a good overview of what this instrument is able to do when it comes to gluten-free products. So first of all, let's start with, let's start with a few numbers. The fact is that gluten-free market is growing strongly. It was once sort of fad, but clearly this is not the case. It is a strong trend that can be explained by many factors, and especially the health benefits of eating gluten-free products. And at least the consumers' awareness of that. There are more and more people that eat gluten-free as part as healthy lifestyle, and not just because they cannot eat gluten. And this is coming to a point where the gluten-free label itself is becoming a selling argument. So this is why you can see now the gluten-free label in many products that do not contain gluten to begin with. And this is the case here. You can see the gluten-free mention here on a bottle of water. That's always very funny to me, but well. And in addition to that, well, now we can count on improved marketing activities and distribution channel. And all of that makes that there is a wider availability of many gluten-free products. I don't know about you, but in my local supermarket now they have this gluten-free section, small gluten-free section, but still it was not here just 5 years ago. And what is interesting as well is that the gluten-free bakery products inside of the gluten-free product market is the most important one, and is going to keep it that way during the next few years. But what is gluten? And why it is such a problem? Why do we keep hearing about it? And why do some people need to avoid it? Well, because gluten is a group of protein. It's just a protein in the end, mainly gliadins and glutenins. We can find gluten in various cereals such as wheat and barley and rye, etc., etc. And the thing is that there are many people who have gluten-related disorders. So different kinds of disorders. We can have wheat allergy, gluten sensitivity, and the famous celiac disease. This disease alone affects 1 in every 141 people in the US, which represents more than 2 million people that cannot eat gluten. Because the fact is that you don't cure celiac disease. There is no drug for that. So the only way of keeping it under control is to eat a strict gluten-free diet. So when you count only those people who cannot eat gluten, you have more than 2 million people just in the US. And then you have all of these persons, plus all of the persons who think that eating gluten-free is healthier for a reason. So this is really a big market that needs to be addressed, and it is addressed more and more efficiently today. But the difficulty is that gluten is so great for making bread. You need to think of gluten like this magical, miraculous net that will hold the bread together. As it develops, the gluten network will give a product that is both extensible, meaning able to stretch, and so able to give in the end the proper volume to the bread or to the croissant or to whatever you want to produce. And also it's elastic, it's able to hold a shape. And that's very important to be able to retain the gas inside of the product during proofing and then later on during baking. So it's because it is both extensible and elastic that gluten gives bread in the end its unique texture. And there is no other product in the world to present this set of properties. So the question is, how how do we make gluten-free products? How come? How can we? Well, the truth is it's difficult. There are a lot of challenges, but this is far from impossible. Because as you know, there are a lot of gluten-free products in the markets. There are just a few challenges to overcome. So this is what we are going to see right now. The first challenge is that generally gluten-free products try to replicate the gluten version of the same product. Like if you take a small kid playing with his friends and they all have these Oreos as snack, well, he's going to want some Oreos as well, even if he's celiac. And so he's going to try to look and search for the closest possible option in terms of flavor, of texture, of shelf life. And in the end, all gluten-free products, they are trying to reach the same quality standard that correspond to conventional gluten-containing products. That's the first challenge. The second one is that there is a lot of raw material available for making gluten-free products. Like you have rice, rye, pea, and this and that. So, but we will come back to that later on. And you have a large variety of raw material available, and each of those variety of those raw material, they have a certain variability, just like wheat flour. And that will depend on the crop, on the climate, that will depend on the miller, that will depend on many things. And so just like wheat flour, it becomes important to follow the quality of raw material in order to make sure that the process will go without a problem and that we will be able to produce a consistent final product. And well, this is where it's a little bit even more complicated, is that yes, we realize that we need to control those raw material, but the quality controls tools that we have right now are not always so adapted. Because the truth is most laboratories, equipment and tests, they are completely focused on the gluten. This is the case of the farinograph, of the alveograph, of the extensograph. They are all measuring gluten properties. And the fact is, starch products, they are mainly made of starch. Well, sorry, gluten-free products are mainly made of starch. And so it would be good to focus a little bit more on the starch parts. So there are tools to measure starch behavior and starch properties, such as the RDA or the amylograph. And these are great tools, but the thing is that they are working on a very diluted dough. And that does not represent the viscosity of a gluten-free dough that a baker is used to work with. So until now, that was really no method completely suited to this kind of applications. So just to come back a little bit to the key ingredients used in gluten-free products. Basically, in the end, a gluten-free flour is a composite flour, which is made of different things. And amongst that, you can find gluten-free flours and starch, such as rice or corn or quinoa, whatever the flour, and this is the base. Let's say this is the base of the composite flour. And then you can sometimes find also tubers and legumes, which can be very interesting for their nutritional characteristics, for their functional properties sometimes, and also for their taste. And you will need some kind of a structuring agent to hold all of that together. And this is why gums and hydrocolloids, they are generally a big, well, not a big, but an important part of a gluten-free formulation. And here you can find also different types of gums and different types of hydrocolloids and different also sometimes external protein source, such as soybean or egg. And besides their ability to increase the structure or to improve the structure of the dough and the final product, they have two major functionalities that they allow to absorb water, and also they allow to improve volume. And then finally, you will find enzymes. So enzymes that are used to finalize the formulation and to optimize the dough behavior. And amongst them, you can find alpha amylase, sugar oxidases, transglutaminase. But if we look at all of that, this is just not like it was with flour. This is a lot of different products that can vary tremendously. So this is the real challenge. How do we do to control all of that? Well, this is why I would like to introduce the Mixalab 2. So the Mixalab 2 is a recording mixer. So basically, we will record the consistency of a dough, the evolution of a consistency of a dough submitted to mixing, and also to different cycles of heating and then cooling. And that allows us to have a lot of information on any kind of products. Because the fact is, well, we call that a universal dough characterizer because this is a very versatile equipment. The only limit here with this instrument is the consistency. If you are working with something too liquid, like a crepe dough, it's not going to work. But besides that, it can work with practically anything. And so just to introduce this instrument in a little bit more detail. So here you can see the mixer. In this mixer, we will put flour and we will inject water. The dough will develop, and so we will be able to measure the water absorption. Then at constant temperature, we will see the mixing behavior, such as stability and development time, etc. And then the temperature rises. And here we can see something very interesting, which is the protein weakening. And that will impact the volume of the final product. Then at a certain temperature, we start the gelatinization, which will impact the structure of the creme. And then at high temperature, we will measure the stability of the starch gel, which is a good indication of the color. And finally, the temperature decreases, and we will observe starch retrogradation, which gives us a good idea of the shelf life of the product. So this is a very complete system which provides a very comprehensive information. So we have developed a dedicated protocol for gluten-free products that we have called very obviously gluten-free protocol. So this is a protocol that measures the consistency of a dough according to the time. So this is a protocol that lasts 45 minutes and during which we will apply different temperatures. So at first, we work at 30 degrees. And during this first phase, we are going to measure the water absorption and the mixing properties of the flour or of the dough, including the development time and the stability. And then the temperature increases until reaching 90 degrees. And here what we are going to see is the protein weakening due to denaturation. As the dough heats, the proteins get weak. Yeah, they get more weak because they are releasing water into the dough. And so this is why the dough softens. This is because there are more free water into the dough. And then at a certain point, we reach a temperature which is generally between 50 to 65 degrees. It can vary a lot according to the raw material that you're using. Here, we will observe the starch gelatinization. So this is this part of the curve here. And this starch gelatinization will impact the texture of the final product of the crumb. And it's also going to impact the volume of the product. And then here, we stay at high temperature during 7 minutes. And so this high temperature combined to the mixing will weaken the starch gel that we have created here. And so this is why the consistency decreases, the stiffness decreases here. And this here, this decrease in consistency is related to, well, many different things, including the type of starch, including the damaged starch contents, and also as a function of the amylase activity. And so this is why this part is related to the color of the final product. And then finally, the temperature decreases and we reach 50 degrees to which we stay during 5 minutes. And during this phase, we are going to observe an increase in the torque that is due to the starch retrogradation. This starch retrogradation phenomena is exactly what is happening when you take the bread out of the oven and you let it on the counter for a few days. At first, it's warm and it's so great to eat and it's good. And then you wait a few days and it's completely hard and it's not eatable. And so here, this starch retrogradation is directly linked to the shelf life of the product. So if you have a big increase, then you might observe a short shelf life. On the contrary, if you have a very moderate increase, then you can expect to have a long shelf life. So thanks to this protocol, the Mixolab is able to offer a complete solution for all gluten-free products. And when I talk about gluten-free products, I mean, of course, raw materials, such as rice flour or a buckwheat flour, or all kinds of gluten-free products, and also mixes. So this is what we were discussing before, those composite flour with the starch and the proteins and the HPMC and the enzymes and everything. We are also able to analyze complete formulation, so including egg and fats and milk and all of that. And this is quite funny. It is also possible to take dough from the production line and then to place it into the Mixolab. So to analyze an already made dough that is really representative of your process. And so now this is why I would like to show you a little bit more examples about all of those applications. So here we can see different Mixolab curves for different raw materials. So here we have a Mixolab profile for wheat flour, here for soy, for amaranth, and here for rice flour. What is very interesting first is that, well, we have a curve, whatever the product. So all can be analyzed with the Mixolab with no modification of the instruments and no additional accessories is needed. So this is really a direct analysis. And what is interesting to see is that the shape of the curves are completely different, and that indicate different rheological behaviors. Like if I had to replace wheat flour by one of these three flours, basically I would try to take the one that is the most similar. And clearly here, that would be the rice flour. We have also other ingredients, and we have tested plenty of raw materials. So here we can see buckwheat flour, buckwheat whole grain flour, and also maize starch and potato starch. So all they are quite different. And well, the Mixolab profiles of these different ingredients, they give us very interesting information about their rheological behavior, how they are going to behave online during the process, and how they are going to impact the final products. So in order to illustrate a little bit all of that, I would like to present you a case study that has this is a project that has been done in collaboration with the LEMPA, which is the National Laboratory for Bread Making here in France. And the objective of this study was to select the right flour for gluten-free cookies. So we have selected 6 candidate rice flour, and already just by looking at the pictures, you can see some differences. The color is not always the same. The granulometry appears to be a little bit different. And just by looking also at the moisture content, we can see various moisture content. So then the LEMPA has done cookie baking tests following a standard procedure, a very simple one, using those 6 rice flours. And during the process also, it was possible to detect some differences with the color again, and then with the consistency, with the stickiness of the dough, with all of that. And in the end, we were able to produce different cookies. And just by looking at them, it is already possible to see that they are not the same. The color is not the same. And then the weight and the thickness has been measured as well, and they are not the same. Well, that is actually a good news, because when we measure those flours with the Mixolab, we reach the same conclusion. Yes, those flours are different. They have different rheological behavior. This is what we can see here. If we take, for example, the rice 1, we have a very high peak, when with the rice 6, we have a very low peak. They are all able to produce a certain type of cookie. But if you want to control and master the properties of this cookie, like the thickness and the weight, then you need to select your flour. And in this, the Mixolab can help, because you can then build specifications. And even more than that, this is kind of the cherry on the cake. You can also correlate the result of the Mixolab with the physical measurements. Here in this example, it was possible to correlate the weight of the cookie with the C5 point and with the stability of the dough to mixing. And it was possible to correlate the thickness with the C4 point and with the development time. So therefore, the Mixolab can allow you to really know what to look for. It can help you design specifications using the Mixolab to know that if you want a certain diameter or a certain weight, like it says in your package that you should have 150 grams of cookie, well, that means that you need, I don't know, 15 cookies. Then that means that the minimum weight should be 10 grams. So here, all of those flours, they would not work. Hence the necessity of controlling and selecting the raw material. And in that, the Mixolab can be of great help. So here, this is another example. Here, what we wanted to do is analyze different gluten-free mixes. So these are the composite flours with different kinds of material, different kinds of many things. So the challenge here was to control the consistency of a very wide variety of gluten-free mixes. Mainly, we have bread mixes, but also cake, biscuits, or biscuit mixes. And by using the Mixolab with the gluten-free protocol that I was talking about for all the mixes, we wanted to offer a real strategy for analyzing those gluten-free mixes. So if we just focus on the gluten-free bread mixes, so just the gluten-free bread mixes for making bread, we can see that for making similar final product, we can use different formulation strategies. Sometimes buckwheat flour is used, and sometimes it is not the case. Sometimes tapioca flour starch is used, and sometimes it's not the case. And this is it for all of those products. So according to the bread mix, various ingredients and, of course, various proportion of all of those ingredients are noticeable. And so obviously they will not have the same behavior. And of course they don't. So these are the results of the Mixolab, and we can see very clearly that the bread mixes showed various Mixolab profiles during both mixing and heating. We could see a broad range of different consistencies and torques. Like for instance, the bread one here, it has the highest peak to begin with, contrary to the bread 4, who had the lowest one. Basically here, what's important is not which one is the highest or not, is that all the mixes characteristics can be analyzed thanks to the Mixolab, and so they can be followed. If you can analyze your raw material, but you can't analyze your finished product, that's an issue. And so this is why we wanted to make sure that it was also possible to check the final product, which in this case here is the composite flour. And so we wanted to go a little bit more further by putting in those gluten-free mixes, following the producer's recommendations for making bread. And so we've put oil and salt and sugar and milk and eggs sometimes into the Mixolab in order to see what was the impacts And so here, once again, we could see a broad range of behaviors. And that demonstrates, again, the importance of quality control. Because when a customer buys, I don't know, the gerblé mix, well, if he follows the recipe, he will have something like that. And this something is the good behavior. He doesn't want it to change. So that is the point of, again, the importance of quality control. So here I wanted to not illustrate because it's a little bit different, but I wanted to show a case study where the objective was to develop a new formulation for a healthy gluten-free muffin. So that was done in collaboration with the London South Bank University a few years ago. And it was a PhD student, it was a PhD project. And the objective of the guy who was getting his PhD was to develop a simple approach to design a gluten-free product with similar rheological behavior as a standard wheat flour and final product's characteristics matching the gluten reference. So basically, this is the dream for any kind of gluten-free products. So this was done in several steps. The first step was to define the formulation, and the strategy that was used was to copy the behavior of a standard muffin flour. So basically, he selected a wheat flour that was used for making muffin, and he tried to replicate that, but only using gluten-free ingredients. And one more challenge, only using clean formulation. And when I say clean, is that, for instance, he didn't want to use any gum or any hydrocolloids because this is generally E something. And so that's not looking good in the labels, in the formulation. And also he wanted to limit the amount of starch that was going to be introduced in the formulation. Well, I'm not saying that starch is bad. Starch is very fine, but it's like everything. You don't want to have too much of this. So if you plan to running a marathon, then eating a lot of starch as well, it's good. It's in the end, it's just a big sugar. But if you're not planning on running a marathon and that you are planning a Netflix night, well, maybe too much starch is not the way to go. So he wanted to use a clean gluten-free formulation. And in order to replace the functionality of gums and starch, he wanted to add a mix of hemp and pea protein because pea protein are used traditionally in gluten-free ingredients because they increase the water absorption potential. So that's very good. But hemp is kind of a new protein to use in the baking world. And the thing is that previous studies have shown that hemp protein had characteristics not close to the gluten, but it was forming kind of a network that was allowing the product not to crumble so much. Gluten-free products have a tendency to crumble somehow. And so to validate this strategy, he then tried to assess the usefulness of gums and added starch. Then step 2 was to confirm the formulation by making baking tests and sensory analysis. So here I must say that this step 1 has been done entirely with the Mixolab. So here the baking tests were only necessary to confirm the formulation and not to work on it. Well, and final adjustments, let's say. And then final step was to check the improvement of nutritional profile. So here we checked the content of fiber and the glycemic analysis of the participants who tried the muffin. So here are the results, and here is a little bit more in detail the strategy. Here we can see on this graphic the standard muffin flour here in yellow. And here we can see the gluten-free mix, the clean gluten-free mix with two different proteins. Here, this is 100% pea protein, and here, this is 100% hemp protein. And as you can see, the pea protein, they increase a lot the water absorption. So everything is good for that. But we can also see that there is, with hemp protein, a real gain in stability. So here we used the blending law, which is one of the assets of the Mixalab software that allowed us to find what was the best protein blend to get as close as possible to the standard curve. And here we found out that if we use 80% hemp and 20% pea protein, well, we obtain a curve that is basically parallel to the standard muffin curve. So in the end, this is just a matter of hydration to reach this curve. Well, additionally, he wanted to make sure that gum and starch was not necessary to improve this formulation. And so what he did is put gum and starch into this new formulation here. And what he observed is that in the context of this formulation, gums or starch was not allowing him to get closer to the standard curve. And so he decided not to use them. And well, baking tests confirmed that it was not necessary in the case of this formulation. So in the end, a healthy gluten-free product was kind of easily developed because, well, the Mixolab results have shown that we could avoid some technological challenge by incorporating pseudo-cereals and up to 30% protein. And that was not impacting the sensory results. When the participant tested the product, well, only 12.5% of them believed that the products that they were eating were healthier, and only 45% of them believed them to be gluten-free. And additionally, the nutritional characteristics have been improved a lot. The Mixolab has confirmed that in the context of this formulation, it was not necessary to use xanthan gum or starch. And the results of the fiber analysis have shown that an improvement of the fiber level available. And also the participant have been testing for glycemic testing, and it showed no significant spike in blood glucose after ingestion. So very successful formulation, very successful project. And well, in addition to all of that here, the Mixolab was a great asset to allow him to not waste too many time making a lot of, of baking tests. It assays a considerable amount of baking tests, and so a lot of time and a lot of sample. And in his case, it was very important because hemp protein can be kind of expensive still. And then finally, I wanted to address an interesting challenge, which is to go a little bit further in the quality control and not to only control the raw material or the finished product, but also to control what happens in between. We have seen that it was possible to control the quality of raw material, to develop a new gluten-free product. And we've also seen that it was possible to analyze the final product, which is composite flour. But this composite flour, when you turn it into a bread, do you know what is happening in between? Well, this is the point here of this application. And the point here is to have a better understanding of the entire baking process in order to maintain a consistent product quality. So the point is to take at key points of the productions is to sample dough and then to put it in the Mixolab. So the strategy here is to start with the end product's quality in mind. Basically, you just need to define what is a good final product for you and for your consumers. Like, for instance, are they interested in the color or in the volume, the diameter, the structure, the texture? So first, define what is a good final product, and if possible, collect data from visual inspection because they are objective. And so this is way easier to work with objective data in the end. Then the second step is to characterize, well, all those key steps in the process by taking dough and putting it in the Mixolab. And by doing that, we can define what is a good dough at every step. And so if you have a behavior that is completely different, you know that something is wrong, and so you can anticipate. And finally, by knowing what is a good dough that gives a good final product, well, you can select your raw material and you can select your composite flour better. You can control it better. So here are a few examples of results that we have obtained. Here are the incoming flours and the step after mixing, after resting, and after proofing. And so basically by doing that, it becomes possible to spot if something is wrong. Like here, for example, all the curves are here. Well, let's say that tomorrow a curve is here. Well, basically, it's probably will be a difficulty during the process or with the quality of the final product. So here we can react. And this is the same thing at every step. So in the end, the Mixolab is a great tool to qualify dough rheological properties that completely complement the baker's experience. So it's a quick way to measure the dough from key baking steps, and then you can identify an incorrect behavior and anticipate any issue. So if the flour behavior was not the same, and you know that's coming from the flour, and then you can blend it with something else, you can use enzymes and ingredients to attempt to correct it, or you can even reject it. And if it's coming from, let's say, the second mixing, well, then you know what step is to blame. If everything was fine here and fine here, and all of a sudden here, nothing is in the spec, well, that means that something was wrong with the second mixing here. So this is where we should focus. That's a precious information. In the end, knowing that the Mixolab can help gluten-free bakers to develop troubleshooting guides to improve their overall product quality. So, in a nutshell, the Mixolab is a great tool, very useful for gluten-free product development. You can select the best alternative raw materials. You can control their regularity, adapt the formula depending on their variability. You can determine an optimum water level, select right ingredients to replace gluten functionalities, and also analyze the impact of enzymes, of gums and hydrocolloids. And you can analyze the rheological properties of gluten-free mixes and dough. Also sample dough from the process in order to have a better control of your entire process. So if you are interested in a specific application, or if you want more information about what can be done, well, we have extensive data that we would be happy to share. So don't hesitate to contact BAKERpedia or Chopin directly. And well, I just wanted to say a few words because I talked a little bit about vision inspection. And it happens that working with a vision inspection product, just like the TheaView here, that you can see is the perfect companion for the Mixolab. Because, well, the TheaView gives you objective data on the final product, on the 2D dimension, on the 3D data, such as volume, and also on color, on many different things. There are hundreds of applications. And if you correlate those data with the objective data of the Mixolab, you are truly in the verge of a completely, well, better quality control process. So I'm going to stop here just by saying that definitely we have done a lot of extensive research with this device concerning the quality of gluten-free products. And so it was really nice for me to be able to present that to you today. And if you have any questions, I would be really happy to try and answer. So thank you very much for your attention.
I want everyone to keep quiet. I want everyone to remember this point in time. This is really critical because what you just saw was a historical moment in time.
Wow.
What the Mixalab has done for gluten-free flours that the farinograph has done for wheat-based flours. This is how important this point in time is, okay? And BAKERpedia is so proud to partner with Chopin to bring this to you.